Alright guys, in this video we're going to be looking at factoring polynomials with graphs and tables. Now as far as what factoring is taking sort of a general form of an equation and then breaking it into pieces, sort of expressions, these smaller expressions. We're going to be doing this with tables and graphs. If you will notice, I've gone ahead and filled in the graph and the tables for these two first examples. So if you want to go ahead and pause the video here and fill in the tables. I did this just using the calculator. I graphed it on the calculator and I just pulled up the table and got all the values for that. So if you want to pause the video and fill in the tables, then we'll continue from there. Okay, so now when we are factoring these things using these tables or graphs, one of the most important things we're going to be looking for is what's called x-intercepts. Okay, so if we go down here to these questions, how do you identify the x-intercepts from a graph? Well, in a graph, it is where it touches the x-axis. Okay? And now if we're using a table, in other words, it's going to be where y equals 0 would be our way to identify it. Okay? So let's look at our first example up here. X squared plus x minus 6. Well, our x-intercepts, if we look, where y equals 0, they are found here, and they are found here. So we have one at 0, then we have another, I'm sorry, not at 0, one at negative 3, and our other one is at a positive 2. Okay, so let's look at our second one. Well, here we have y equals 0 at negative 2, at 1, and at 3. Okay, so let's go ahead and write those down. Negative 2, positive 1, and a positive 3. All right? So what do you notice about the number of x-intercepts and the degree of the function? Well, if you'll notice here, the degree of this function is to the second power, and we have 2 x-intercepts. On our second example, the degree is to the third power, and we have 3 x-intercepts. So those are going to kind of line up usually. Okay? So they are the same. All right. So how can we use the x-intercepts to write the factored form? Okay? Well, this is what we're going to do. If we go up to our first example, notice our x-intercepts are negative 3 and 2. So we're going to take those two values, negative 3 and 2, and we're going to write two factors based off of those. Now in these factors, the sign is going to be the opposite of what the sign originally was. So for negative 3, we're going to put x plus 3. And for our positive 2, we're going to put x minus 2. Okay? So now if we look at our second equation, we have negative 2, positive 1, and a positive 3. So now we're going to have 3 pieces. Okay? So our negative 2 becomes an x plus 2. Our positive 1 becomes x minus 1. And our positive 3 gives us x minus 3. Okay, so we just change the signs and write them with the x. All right, now what if it isn't a whole number? Okay, what if we get these x-intercepts here? Well, if I was going to write these as factors, my first one would be x minus 4/5. My second one would be x minus 3 for that positive 3. And my last one would be x minus 1/7. Okay? Well, we don't normally write these factors with decimals. So what we're going to do here, there's a little bit of algebra involved, but we're just going to use this sort of little trick, we'll call it. We're going to move the denominator, 5, in front of the x. So that becomes 5x minus 4. Our second one doesn't have a fraction, so it stays as x minus 3. Then our last one, we're going to move that denominator 7 in front of the x, and it becomes 7x minus 1. Okay? All right, so let's look at one more example. Okay, so let's find our x-intercepts using this table here. All right, so remember our x-intercepts are where y equals 0, so there's 1 there, 1 there, and we have another one here. Okay, so those x-intercepts are negative 0.75, 2.5, and 5. All right. So there's 2 decimals, and we don't want decimals in our factors, just like we don't fractions. So we're going to turn those decimals into fractions. Well, negative 0.75, if we use our calculator, convert it from fraction to decimal, becomes negative 3/4. Okay, and our other decimal is 2.5. 2.5 becomes 5/2. Okay, so let's rewrite these as factors now. All right, so our first factor is x plus 3/4, because remember we changed the sign from a negative to a positive. Our second one becomes x minus 5/2 for the positive 5/2. And then our one that wasn't a decimal to begin with, our positive 5, just becomes x minus 5. Now, remember, we're going to take these denominators, we're going to put them in front of the x. Okay, so when we rewrite these, this becomes 4x plus 3 times 2x minus 5 times x minus 5.